Okay, we're going to continue our study of the implication rules, the first set of implication rules with hypothetical syllogism. So the form of a hypothetical syllogism is if P, then Q. If Q, then R. Therefore, if P, then R. So notice that the first conditional here, the consequent of it is the antecedent of the second conditional premise. And the conclusion goes from the antecedent of that very first conditional to the consequent of the second conditional. So you can think about it this way. Well, what's the concrete example they give us here? Oh, they don't. Let me tell you one. So let's say if I said, if it's hot outside, then I'm going to wear my red socks. If I wear my red socks, then I'll probably go for a long walk. So therefore, if it's hot outside, then I'll probably go for a long walk. Or if you give a mouse a cookie, he'll probably want a glass of milk. If he gets a glass of milk, he'll probably need a napkin. So therefore, if you give a mouse a cookie, he'll probably need a napkin. That's the basic idea. Now, so you got two conditional premises, and you can conclude to a conditional conclusion. So valid applications. If H, then S or N. If S or N, then not R. Therefore, if H, then not R. And there's this one, similar one over here. I won't read through it. Now, misapplications, ways that you can screw this up. If K, then L or not R. If L or not R, then M. Therefore, if K, then M. That looks so good, though. What could possibly be wrong with that? What is it? Where'd they screw up? Look at this. The consequent for line 1 is L or not R. The antecedent of line 2 is L and not R. They're different. So you don't have if P then Q, if Q then R. You've got if P then Q, if X then R. So you don't have like a middleman Q that bridges the gap here. So it doesn't follow. If K then M doesn't follow. So you got to watch yourself. That Q has really got to be the same in both lines. Or look at this other one here. If B or C, then D or E. If D, then F or G. Therefore, if B or C, then F or G. Again, what's the problem? The consequent here, D or E, is not the same as D, the antecedent in the second line. They've got to be identical. Both got to be Q, as it were, or it doesn't work. All right, disjunctive syllogism. That can have two possible forms here. It's really just two ways of saying the same thing. So one premise is a disjunction. Remember, a disjunction is an or statement, a wedge statement. So P or Q. The other premise is going to negate one of those disjuncts. It's going to say not P, or it could say not Q. And what follows from that is that the other one must be true. If you're like, look, at least one of these has got to be true, and it's not this one, it's got to be the other one. All right, so here's valid applications. Premise 1, either if R then P or S. Well, it's not the case that if R then P, therefore S must be true. That's a valid disjunctive syllogism. Or you could run it the other way. Either if R then P or S. Well, it's not the case that S, therefore if R then P must be true. Here's ways to screw it up. Either F or G or H. Well, it's not the case that F, therefore H. What went wrong? What went wrong? Look, they didn't negate the disjunct. They just negated part of the disjunct. If you wanted to make this a valid disjunctive syllogism, you have to say it's not the case that parentheses F or G, close parentheses, therefore H. But they didn't do that. So it doesn't follow. All right. So how do we apply these? How do we use these rules in a proof? Here's what it's going to look like. You're going to be given something like lines 1 through 4. Here's a bunch of premises. Here's what the pieces on the board that you got to work with. And then there's going to be this backward slash and another statement. And that's the conclusion you're supposed to get to. And your mission is prove Q on the basis of these given premises using the implication rules that you've got. And here's what you'll do. Here's what it'll look like. So in this one, they say, first of all, they proved 5. They proved that not S is true. How'd they prove it? Well, they proved it from line 1 and line 3, and by applying the disjunctive syllogism rule to those 2 lines. Now look at this. Line 1 is not R. Line 3 says R or not S. Well, okay, so line 3 is the disjunction. Line 1 says one of those disjuncts is false, so therefore you can conclude the other disjunct, not S, is true. That's how you write out. You write out the justification to the side here. Here's the lines, and here's the rule that I'm applying to those lines. Line 6 then is derived by applying the modus tollens rule to lines 2 and 5. So line 2 says, if P, then S. Line 5 that we just proved, we can then now use that as a premise. It says not S, and it follows from that therefore not P. So now we've got not P. And now we can finish the proof because we can apply the modus ponens rule to lines 4 and 6. If not P, then Q. But line 6 says, well, not P is true. So therefore, Q is true. Now, we'll say more in other videos about how did they know which steps to do first and second and third? How did they know how to get there? That takes some skill. But I want you to see what it looks like when it's done. You're given the premises. Here's the conclusion. You get there by justifying each step, referring to the relevant line numbers and the inference rule that justifies the step until you get to the conclusion. All right, an example here. Let's say you're given as a premise, if T or S, then P and not R. But it's not the case that P and not R. Now, if you apply modus tollens to lines 1 and 2, what's the conclusion that follows? Here's your conditional. Here's the negation of the consequent. What follows is the negation of the antecedent. And what is the negation of the antecedent? Very good. It's line 3 here. It's not the case that T or S. Be careful to keep those parentheses in here so that the negation ranges over the entire compound statement there and not to just individual parts. Here's another example. We've got S, or it's not the case that if P, then Q. Line 2 says, well, not S. Now, if you apply the disjunctive syllogism rule to these 2 lines, what does it give you? You negated one of the disjuncts. What follows is that the other disjunct is true. So what's the conclusion? Yes. It's not the case that if P, then Q. That's the other disjunct. That must be true. All right, we're going to take a break there.